So here is problem number 1, simplifying expressions. Here we're going to simplify 5 times the quantity 2x plus 3 minus 3 times the quantity x minus 4. Now this is a common SOL or EOC problem on expressions. So the first step here is for us to distribute the 5. As you can see here, the 5 and the negative 3. So let's go ahead and do that. So we'll start with 5. We're going to distribute it to each term within the parentheses, to the 2x and to the positive 3. And so when we do that, we get 10x plus 15. Okay, and then we are going to distribute the negative 3 to x and to negative 4. So that becomes negative 3x plus 12. For our next step, we're going to combine like terms. We have 10x and negative 3x, which equals 7x. And then we have positive 15 and positive 12, which adds up to positive 27. So our final answer is 7x plus 27. And so I want you to be careful here. The tip I would like to leave with you is to always distribute negatives carefully. All right, so let's go ahead and move on to problem number 2. Here is problem number 2. We have to solve 4x minus 8 equals 12. I will say this is a basic SOL or EOC equation. The first step we're going to take is add 8 to both sides to isolate the term with x. We'll add 8 on the left and on the right. And so when we do that, we know that the 8's cancel out. We're left with 4x, bring down your equal sign, add 12 plus 8, which equals 20. And we have to divide both sides by 4. So on the left and on the right, and we see here that the 4's cancel out, and we're left with x equals 5. That's the final answer. The tip I will leave you with here is use inverse operations. Subtract and add first, then divide and multiply. Okay, so on to problem number 3. Okay, so for problem number 3, we're going to solve the inequality. I'm going to start by rewriting it so that way you can see the original inequality problem and it keeps everything clean. And so the first step we're going to take is to subtract 2 from both sides, from the left and from the right. And when we do that, we are left with 3x, because notice the plus 2 and minus 2 cancel out. That is 3x is greater than 14 minus 2, which is 12. Okay, the next step to take is to divide both sides by 3. So from the left and from the right, we're dividing by 3. Notice that it is a positive 3. The 3's cancel out. We have x is greater than 12 divided by 3, which is positive 4. And the inequality stays the same because 3 is positive, right? We divided by a positive 3. So the final answer here is x is greater than 4. Now I will leave you with a tip here. If you divide by a negative number, make sure you flip the inequality sign. All right, so let's go ahead and move on to problem number 4. So for problem number 4, the question asks us, does this table represent a linear function? So the first step to take is to look for a consistent change. I noticed that each time x increases by 1, the value of y increases by 2. So let me go ahead and show you that. So let's take a look at the x values. We see that it increases from 1 to 2, and then from 2 to 3, and then from 3 to 4. And when you take a look at your y values, we see that the values increase from 2 to 4, from 4 to 6, and from 6 to 8. Okay, and so now we can go ahead and interpret this pattern. Because the change in y is the same each time, the values do increase by 2. That tells us the rate of change is constant. So to answer the question, we will go ahead and say yes, that this table represents a linear function. And that is the final answer. So a quick tip I want to leave you with is that a linear function has a constant rate of change, meaning that it does not change. All right, so let's go ahead and move on to number 5. Here is problem number 5, where we have to find what the y-intercept is for y equals 3x minus 1. And the y-intercept is the constant term in y equals mx plus b form. So if you recognize this equation as y equals mx plus b form, then you know that the constant term is -1. So here b is equal to -1. Or you can plug in x equals 0. So where you see this x in the equation, just replace it with a 0. And so that looks like this. Y equals 3 times 0 minus 1, and that equals -1. Okay, so that's the final answer, -1. And I'll also leave you with this tip. It's where the line crosses the y-axis. Okay, so let's go ahead and move on to number 6. So here is problem number 6, and it says a rectangle has length 15 feet and width 8 feet. What is the area? This question right here is very important. This lets me know that we will be using the area formula for a rectangle. And if you can recognize that, go ahead and jot it down. That is area equals the length times the width. Okay, and so we're given that the length for this rectangle is 15 feet. So I will go ahead and highlight that. The length is 15 feet, and we're given that the length is, we're given that the length is 15 feet and the width is 8 feet. Let's go ahead and label the rectangle. You can go ahead and do that if you want to help you visualize it. I would suggest that if that's something that would help you, okay? So we have the length as 15 feet, and the width is given to us as 8 feet. So use the formula and plug in your numbers. So we have area equals, and that is the length is 15, that's 15 feet, times 8 feet. And so that equals 120. But it is not enough to just say 120. You always need to include the units on the EOC. So this is 120 square feet, or feet squared. And that is the final answer. So let's move on to problem number 7 now. Okay, problem number 7. And it reads, in a right triangle, the legs are 3 centimeters and 4 centimeters. What is the hypotenuse? So this question is a very important question. And so you have to be familiar with that formula, the Pythagorean theorem formula, and that is a squared plus b squared equals c squared. So let's go ahead and write that down here. So that is a squared plus b squared equals c squared. And we're already given that 2 of the 3 legs are 3 centimeters and 4 centimeters. So let's just go ahead and label A as 3 centimeters and B as 4 centimeters. And we don't know what C is yet. That is our hypotenuse. And now we can use this formula to plug in the numbers. So we have a squared, which is 3 squared plus b squared, so that is 4 squared, equals c squared. And so we know that 3 times 3 is 9, plus 4 squared is 4 times 4, which is equal to 16, which is equal to c squared. 9 plus 16 equals 25, equals c squared. But now we have to use inverse operations. So since we're squaring, we have to take the opposite of that, which is to take the square root of. So we're going to take the square root of 25 and c squared. And when you do that, you're left with c on the right. And then on the left, ask yourself what number times itself equals 25, and that is 5. So that means that the hypotenuse is 5 centimeters. And that is the final answer. I'll also leave you with this. The hypotenuse is the longest side, and it's opposite the right angle. Okay, so with that, let's move on to problem number 8. Problem 8. Here we have to find the volume of a cylinder with a radius of 2 centimeters and a height of 7 centimeters. And we have to use pi equals 3.14. So first of all, we are given that the radius is 2 centimeters. So let's go ahead and label that. And so we have our radius right here. And let's label that as 2 centimeters. And we're also given the height of 7 centimeters. Our height here on the cylinder is here. And we'll place 7 centimeters. Okay, and so now let's go ahead and take a look at the volume formula, and we'll write it as V equals, and that is pi times the radius squared times the height. And so when we're filling in the values, let's go ahead and pay close attention. We're told that we have to use pi as 3.14, okay? So let's go ahead and write that here. So that's 3.14 and times the radius squared. So we know that the radius is 2 centimeters, but we also know it has to be squared according to the formula. And we're going to multiply this by the height of 7 centimeters. And that equals 87.92 cubic centimeters. And that's the final answer. Okay, and try to remember the formula. If not, it's on the EOC reference sheet, but make sure you're referencing the correct volume formula. Make sure it's for a cylinder, okay? So let's go ahead and move on to problem number 9. For problem number 9 here, we have to find the mean of the data set. And so we have 4, 8, 10, 12, and 16. So let's go ahead and find the sum. So let me go ahead and change the color to black here. So I'll write sum, which is equal to, and you're adding these data points together. So that's 4 plus 8 plus 10 plus 12 plus 16, which equals 50. And then as far as the mean is concerned, well, the mean is equal to the sum, which is 50 divided by the number of data points, which is 5, and that equals 10. So the mean is 10, which is the final answer. So just remember, mean is the average, and that's the sum divided by the number of data points. So with that, let's move on to number 10. Here in problem number 10, it reads, a scatter plot of study time versus test scores shows points increasing from left to right. What does this mean? So think about and look at the trend line that you see here. So just look at it, and it is increasing from left to right, and so that tells you that as study time increases, so does test scores. So that lets us know that this is a positive correlation. So we'll write positive. So that is positive correlation. Okay, and that is the final answer. But I will leave you with this. I will say that if there is no correlation, just know that the points are random. So they will look something like this, just all over the place, kind of clustered. You know, and then if it's a negative correlation, it will slope downward. So sort of like this. Okay. So let's go ahead and move on to problem 11. Problem 11. Here it reads 6 cups of flour make 4 batches. How many cups are needed to make 10 batches? So we know that this is proportional reasoning, and we have to find out how many cups are needed to make 10 batches. So that's important here. So since this is proportional reasoning, we can go ahead and set up a proportion. So let's go ahead and do that. And so we have 6 cups, and I'll place a small c here so we can keep track of our units. So that's 6 cups of flour make 4 batches. So that is 6 to 4. So, and I'll place a small b here. So this is our given ratio, and that's equal to the second given ratio. How many cups? Well, we don't know that, so we'll place the c here. And that is over 10 batches. So we have 10, and we'll put a little b here. And like I said, that's to keep track of the units. Now, as you can see, we have a given ratio, like units. So the like units are beside each other. All right, and so now all we have to do is multiply, cross multiply. So we see here we have 4 times c, which equals 4c, and that is equal to 6 times 10, which is 60. So solving for c, you'll go ahead and divide by 4 on both sides, and we are left with c equals 60 divided by 4, which is 15. So that means it takes 15 cups to make 10 batches. And that's our final answer. All right, and so let's go ahead and move on to problem number 12. Okay, problem 12, and it reads, the original price is $40, the new price is $50. What is the percent increase? So if we're looking for a percent increase, we know that there's the original price and the new price involved. And so since there's a change in price, that lets us know that we have to subtract the original price from the new price. Okay, and so let's go ahead and do that. So that is 50 minus 40, which equals 10. So that's the change. But you have to take that change and divide it by the original price and multiply it by 100. And so we know that it's 1/4 times 100, or you can say 0.25 times 100. And you see here that the decimal will move 2 places over to the right, which gives us a whole number of 25. So that's not enough. 25 what? Well, that's 25%. 25%, because it's asking us what is the percent increase. All right, and that's the final answer, 25% increase. And I will also leave you with this. Just remember, use change divided by the original 4% change. Okay, so let's go ahead and move on to number 13. Problem 13 says point A, -35, is reflected across the x-axis. What is the new point? So let's just say that you have your point here and it's at -35 as stated. And when you reflect it across the x-axis, you can see that the new point is now -3, -5. And that is the final answer. So I will leave you with this. When you flip across the x-axis, the y changes. When you flip across the y-axis, the x changes. So with that, let's move on to number 14. Here is problem number 14. Before we set up a proportion, I would like to label the triangles. So we have a small triangle and a large triangle. They are not drawn to scale, but let's go ahead and follow the information that we're given here. So the small triangle side equals 4 centimeters. So I'll just choose a side and we'll say that this side is 4 centimeters. And we're also told the large triangle side is 6 centimeters. So we'll place that to the corresponding side. And so now we have to label the small long side, which is equal to 10 centimeters on the small triangle. That is 10 centimeters. And last but not least, we have the large long side, which is x. And notice that is a corresponding side to the small triangle as well. So now we can find out what x is by setting up a proportion and solving for x. So let's go ahead and do that. So we see here that we have 4 centimeters, which is corresponding to 6 centimeters. And then we have set that equal to, and then we have 10 centimeters, which corresponds to x. And so now we can go ahead and cross multiply. 4 times x is simply 4x equals 6 times 10 is 60. And then all we have to do is divide by 4 on both sides. The 4's cancel out and x equals 60 divided by 4, which is 15. So that means that the large long side is 15 centimeters. And that's the final answer. So a tip here is set up proportions for similar figures. If you need to draw pictures, go ahead and do so. So with that, let's go ahead and move on to number 15. Here is problem number 15. We have to write this number in scientific notation. And so as a reminder, a number in scientific notation is the product of two factors. The first one being a decimal number that's greater than or equal to 1, but less than 10. And the second being a power of 10. So as you take a look here at this decimal number, we have this decimal point. What we're going to do is create a box, and we're going to end it at a number that is greater than or equal to 1, but less than 10. And so that is between 5 and 2. So that's the decimal number right here. And let me see if I can get this right. Yeah, it's between 5 and 2. So the decimal number here is 5.2, and then times 10 raised to however many numbers are inside the box, and we can see that there are 1, 2, 3, 4. So that is 10 raised to the -4th power. That's the final answer. So with that, I will leave you with this tip. Small numbers use negative exponents. So that's the end of this review. I hope it was helpful to you. I wish you the best of luck, and as always, keep practicing and stay tuned for more calm, clear math lessons right here on Math by TV.